Hello, my name is Mikko Pihlatie. I'm the coordinator of Drivemode, a Horizon project on integrated modular and distributed drivetrains for electric and hybrid vehicles. And I will now present the status and results from our project. We are a consortium of 12 partners totally from 6 different countries. From Finland, we have VTT and Danfoss Editron. From Sweden, BorgWarner, Chalmers University, and NEVS. From Germany, ABL, Semikron, and Technical University of Ilmenau. From Austria, Thien eDrives. Slovenia is represented by University of Ljubljana. And then Italy, from Italy, we have Icons and Schere. Totally 12 partners, 6 countries. We started in November 2017 and will complete the project at the end of March next year, 2021. The main objective of the project is development of next generation electric drives for highly efficient, compact, integrated modular drivetrain. And technically speaking, we are aiming at 30% increase in torque and power of the e-motors, 50% decrease in maximum operating speed of the motor whilst halving the motor losses, 50% increase in the power density of motor power electronics, and 50% reduction in losses, and the reduction of cost and materials consumption of the components. Distributing the tasks within the consortium, so we have ABL, University of Ljubljana, Thien eDrives, and VTT working on the electrical motor design, manufacture, and things related to the motor. On the inverter, Technical University of Ilmenau, Danfoss Editron, and Semikron. On the gearbox and mechanical transmission, BorgWarner and VTT. Chalmers University working on the integration design of the IDM with a view also to the demo vehicle powertrain, driving cycles, and so. Schere working on the cooling, thermal management cooling circuit. On the IDM, Danfoss Editron is integrating the different components into the IDM integrated drivetrain module, with VTT providing support on testing, data collection, instrumentation, analysis, performance analysis, and results consolidation. Then NEVS working on the demo vehicle with the vehicle platform and integrating the 2 IDMs into that vehicle. And finally, Icons on dissemination and exploitation. The contents briefly: on the IDM level, we have silicon carbide inverter with a 20 kilohertz switching frequency, 140 amps current. On the machine side, high-speed permanent magnet synchronous machine, 75 kilowatts of nominal power, up to 20,000 RPM, and a 3-stage high-speed gearbox with high efficiency around the nominal points of use. Electrical machine design has been looked into with the high efficiency and the efficiency map in mind, so that we can cover in the anticipated drive cycles maximum efficiency areas, having then the torque speed and the power speed characteristics as shown here on the graph. On the inverter design, as said, maximum motor speed 20,000 RPM, switching frequency 20 kilohertz, continuous current 140 amps, maximum output power 110 kilowatts, high efficiency 97 at maximum power, and 98.4% have to be calculated for demo vehicle real conditions. Naturally, thermal design aspects have been taken into account through modeling and different analysis. So for placement of the chips, spacing, the thermal flow, and so on, to stay in convenient and relevant operation zones. And summarizing on the inverter side, we have a volume of 2.6 liters hosting the power output of 110 kilowatts inverter volume, and based on silicon carbide MOSFETs. All right, then putting the different components into the IDM integrated module. So that has been completed during this year, and now since a few months we are in the testing phase. Validation of the system performance comprises the acceleration tested 0 to up to 100 kilometers per hour, top speed on flat road, different road gradients, continuous torque and power, peak torque and power, and that validation goes both ways in driving and regeneration modes, naturally, both ways. This is the setup at the Danfoss site where the IDM is in a motor test bench back to back with the load machine, and then the traction machine with flanges and the torque sensing with automated programming, and this enables a very fast forward optimized testing. This is an overview of the type of interface we are running at the testing site. The Danfoss tests have been completed. Now as we speak, VTD is preparing to continue that side to complete the test sequence and then finally analyze and compile the test results and have the main KPIs defined from those. This is a video image from the Danfoss lab where we test the complete IDM setup as shown a couple of slides back in a test sequence and a similar arrangement that VTD will follow later this year and early next year to collect the detailed information on the performance of each of the components, and then also on the IDM performance as a whole. A very important step after that is the demonstration vehicle assembly by NEVs. It's two IDMs back to back here in the front of the vehicle driving the front axle, and of course that the integration entails the integration into the vehicle. On the mechanical side, there's an 800V DC battery pack already existing in the demo vehicle, electrical integration with the different voltages, thermal integration into the thermal management system, software integration with the vehicle management system and a control unit. And this is how it looks in the front. So here we have the two gearboxes, the top inverters here, and the E-machines are just below here, going outwards on each side towards the wheels and the direct driving into the vehicles. Thermal integration has also been, here we have the IDMs up here with the heat exchanger and then the circulation loops. This is the battery system here from the demo vehicle, and then the auxiliary systems and cooling and HVAC and so on. And this is how it looks. The Drivemode demo vehicle pictures from earlier this year, where we have all the key components and contributions by the project partners. And this is the stage that we are now in the middle of the vehicle testing sequence on track. And this is from this field. We are NEVs is running dyno on track, and then the vehicle is transferred to VTD. We are completing tests on the IDM, dyno test for the vehicle, analyzing the reporting of both the IDM and the vehicle performance KPIs versus the original targets of the project. So this is the final 4 or 5 months of the activity, and we are in the middle of that. Thank you very much for joining this session, the presentation on Drivemode. We are very close to in the final months of the project, and very soon we will be able to have the final outcome and results of our powertrain and the demo vehicle performance. Thank you very much.